University, we're doing research into marine microplastics. These are the tiny pieces of plastic we're now finding all over the world's oceans. What we really want to know is whether small marine animals, called zooplankton, are accidentally eating these plastic particles. And if they are, what does that mean for their health and the health of marine ecosystems? In order to address this big question, the first thing that we really need to know is how much microplastic is in the sea and where does it occur? Is it actually occurring in the same parts of the ocean as zooplankton? Because if we find plastics and zooplankton together, then there's every possibility these zooplankton might be accidentally eating these plastic particles. Not all science happens in the lab. Sometimes we have to go out into the real world to be able to ask these questions. So in this case, we teamed up with the Rosalia and joined their yacht, the American Promise, to go sailing off the coast of Maine on the east coast of the United States to go looking for microplastics. Because microplastics are so small, they're less than 5 millimetres in size, and the ocean is so vast, looking for them is actually really difficult. So despite the fact that there is lots of microplastics in the sea, it's a little bit like looking for a grain of sand in a large swimming pool.
Traditionally, a lot of plastic sampling has been done in the oceanic gyres. These are vast areas at the centre of the oceans that tend to accumulate a lot of plastic litter. These areas are very, very low in nutrients and so don't support much marine life. Instead, we decided to focus on the Gulf of Maine. This coastal region has very high nutrient levels in the summer and can support a lot of plankton growth. In addition, the Gulf of Maine has a lot of big cities along the coastline, and so this can introduce a lot of plastic litter into this region. We use specialist computer apps to help us track the currents, winds and tides in the Gulf of Maine to try and find coastal convergence zones. This is where two bodies of water are brought together, and this is where we felt that plastics and plankton might be found together in the same marine environment. So part of our sampling regime was to use Newston nets. These specialist nets help to concentrate particulates from the water by acting like a giant sieve. They're towed through the surface water because that's where most plastic tends to be found. As the net is towed through the water, it concentrates any particulates such as plankton and plastic at the back of the net in an apparatus called the cod end. Once back on board, the sample is processed, and we do this by pouring the cod end through a very fine mesh which retains all the plankton and microplastics within it. That mesh can then be folded very carefully to store our sample.
One of the things you have to be really careful about when you're sampling for plastics in the sea is that you don't contaminate your samples. We need to know that our samples are valid in that the plastic we're measuring is actually the plastic from the sea and not plastic from, say, our clothing or other bits of plastic on the boat which we've accidentally contaminated our samples with. There's a few things we do to ensure this, such as wear cotton clothing, as many of our clothes might contain polyester fibres, and also wear nitrile gloves and make sure our samples get covered quite quickly after taking them so they don't get contaminated afterwards. So at the end of our cruise, we shipped all of our samples back to Exeter, which is where we can make the measurements of exactly how much plastic is in our samples. So the first thing we have to do is digest away the biological material, that's the plankton in the sample, using enzymes, which then hopefully leaves us with just the plastic left on our meshes. What we then do is lots of microscope work to very carefully pick out these plastic pieces by hand, placing them onto another filter. And then we can use a very specialised piece of equipment. It's called an FTIR, which actually just fires an infrared beam through the plastic and identifies whether it's plastic or not, and if it is, can tell us exactly what type of plastic it is.
We typically will base our hypothesis and sampling regimen on existing scientific data. But it's very important that we look at the data that we ourselves produce and don't have too many preconceived ideas of what the results will show us. And that's because as scientists, it's really important that we do a fair test and only report the results that we find accurately. Our key finding was that microplastics and zooplankton can be found in the same parts of the ocean. But what we weren't able to tell is whether the zooplankton that we captured were able to actually eat those plastics in the marine environment. To look at this, we need to complement our field sampling with some laboratory work. In all, we found 4,500 bits of plastic in just under 3,000 cubic metres of seawater. That's the equivalent of 4,500 bits of plastic in an Olympic-sized swimming pool.